like to introduce you to an idea that could change the way we think about the built environment. This idea would be able to work with deliverable existing technologies that allow for our cities and our buildings to work in a similar way as our forests do. My name is Kent Jackson.
And I'm Mina Hasman. We're from SOM, a global interdisciplinary design firm of architects, engineers, urban planners who have sustainability at the heart of the practice. We're here to introduce you the urban Sequoia.
There have been many different conversations that have happened over the last 2 weeks. A lot of them will arrive to answers, but there will also be a significant amount of unknowns that still exist. But one thing is for certain, the climate change is throwing the world's systems out of balance. From the degradation of our ecosystems to societal inequities and economic disparities.
As one of the world's slowest progressing sectors, the buildings and construction industry is at crossroads. We can no longer idle or take incremental steps if we're to meet the 1.5 or even the 2-degree target by the end of this century. Today, the sector emits much more carbon. I'll wait on this one.
Unless you're a seat in the room with a great distance, we're eating or drinking or are minute late. Thank you for your cooperation.
Sorry for an interruption. So today, the sector emits much more carbon than the nature can absorb, with 47% of its emissions directly going into the atmosphere, and already impacting thousands of lives and livelihoods, and jeopardizing the vitality of our communities, economy, and the environment. With the anticipated increase to 2.1 billion people in the next coming decades, the cities will be placed under immense pressure. As the global building stock needs to double by 2060, we need to ensure that our cities are ready for the challenges ahead. The latest global status report by the Global Alliance for Buildings and Construction highlights the urgency of the existing and new buildings to reach net zero target by 2050. But reaching to net zero is simply not going to be enough, and here's why. The environmental damage we see today is a mere result of a 1.1 degree Celsius temperature rise since the pre-industrial levels. And the current trajectories predict that this temperature rise will go up to 4.4 degrees by the end of this century, causing catastrophic consequences. In this light, in this picture, it is essential for all of us to change this trajectory. And the built environment plays a critical role in this change. As architects, urban planners, engineers, investors, city planners, and regulators, we all need to come together to find innovative and creative solutions to change the way we design, deliver, construct the built environments. We need a revolutionary thinking for the evolution of our sector.
So what if we could actually make our cities perform more like forests? Imagine if our cities were a series of interconnected ecosystems, where we can help our cities purify, heal, and regenerate, where urban forests could create a carbon economy, offering a new resource in the resilient growth of our planet. The built environment has to do more than the current ambitions are showing. If individual buildings could act like a tree, where we could actually be able to absorb carbon from the atmosphere rather than emitting it, our future can be the city that is populated with urban sequoias.
And we can do this by leveraging existing technologies and emerging solutions. So this is not a hypothesis. It is very much rooted in today's realities. We just need to look beyond our sector. We can find solutions from nature, as in the example of algae-filled bioreactive facades that you can see here, where we can use facades as a source of energy. Or in material alternatives, such as the example you see here of biobrick. Biobrick is a natural material in which, through photosynthesis, bacteria from algae can absorb carbon from the atmosphere and create a calcium carbonate, which is the rigid compound found in cement. And by demonstrating this simple example, we can see that we can create the simplest form of materials by purely utilizing local resources anywhere and everywhere around the world. And I talked a lot about looking beyond our sector. So the recent and existing technologies of carbon capture and storage, which is currently widely used in industrial purposes, and especially to capture the carbon that is hard to abate from aviation and agriculture sectors, if we bring these technologies into our sector, we can really offer novel solutions. And by creatively incorporating these technologies and systems into our buildings, we can reimagine the design of the built environment and deliver a future, foresee a city that is not only carbon negative, but a regenerative one at all scales and in all contexts.
So our cities, with their rich fabric, varying building types, whether it be a single-family dwelling or if it's the tallest building in the world, they will all require to have unique interventions in order to play their part in the sector's carbon negative future. In the process, that we must really leverage all of our existing cities and what they have to offer. Today, all of our buildings in our cities emit carbon. We need to seek opportunities that will reverse that trend and find ways to sequester carbon. It has been projected that there are still more than 50% of our buildings to be built and constructed by 2050. It's essential that we intelligently densify our existing cities. High-rise buildings are an inevitable way for the way we see for the future of urban growth, especially in these rapid densifying cities where land is very valuable and very limited. By tackling these complexities of tall buildings, we define synergies between the urban development strategies and their systems. By finding rigorous solutions to the tall building typology, we can apply these innovations to other building types around the world. When we look at high-rise typologies, that it's possible to reduce whole life carbon emissions by making a series of enhancements that are already achievable today. As an example, by simply optimizing the building form, we can minimize the amount of material and reduce carbon emissions by 15%. If we can actually further analyze our buildings and maximize our structural stability, as well as reducing the envelope in its energy use through the building form. We can also look at 85% of our building components in looking at prefabricated or modular elements that we would be able to achieve a better efficiency, a reduction of waste, and we'd actually be able to limit the movement of both people and goods that will actually lead to less pollution in our cities. Through these very achievable targets, we would be able to reduce a further 15% of our carbon from high-rise buildings. If we look at integrated systems, in both passive terms and as well as active, a tall building of 60 stories could have up to 30% carbon reduction. The materials that we choose for our buildings will have impact to the environment for several generations. This is where we need to strike a balance with nature, natural resources, and the built environment must be found.
With the advancements in material science, natural materials can really offer a low carbon alternative to the traditional construction materials and even methods, delivering solutions that are affordable for everyone and everywhere. Over the last 100 years, we've been constructing our cities out of steel and concrete by simply opting for an existing sustainable alternative, such as timber, or other materials such as biobrick or biocomposites. We can significantly reduce the whole life carbon emissions of a single building up to 50%. And this is just one building without jeopardizing its structural integrity and durability. Imagine, this is for a tall building, imagine the impact and reduction we can achieve in a low-rise version. And when coupled with advancements of nature-based solutions, such as the algae example I've given before, we can really deliver carbon-negative buildings at scale. Let me walk you through a little bit of the algae example we talked about before. So algae is currently explored and utilized in many sectors, especially in the aviation sector as an alternative fuel, a biofuel. And if we can explore the options of algae and applications of algae, such as the example that you see here on building facades, we can really generate energy in our buildings. And by bringing algae into our buildings, we can generate this energy that can be used for its operations, and as a result, also produce biomass, which can be used for food supplements and or for pharmaceutical products. With the integration of algae alone in a single high-rise building, we can reduce whole life carbon emissions by 25%. And this is just one building. Imagine the impact such system and solution can offer at city scale and in various industries. And with these solutions that are offered through advancements in material science and nature-based sources, and when they're coupled with advanced technologies of carbon capture and storage that we see in other industries, we can truly accelerate dramatically the decarbonization of our sector. As these technologies harvest, absorb, and store carbon, they actually offer a new resource that can be used both in the buildings as well as the city and other industries. An application could be the refrigeration of buildings or refrigeration of pharmaceutical products. In a single building, by the introduction of carbon capture and storage technology, we can reduce whole life carbon emissions up to 75%. And through a collective application of the technologies and systems I just talked about, in a building, we can really breathe life into them. And imagine the built environment sector as a catalyst to help restore the health of our planet.
In this vision, urban Sequoia can collectively contribute to the regeneration of our growing cities, saving 210% carbon at scale. And also with the possibility of creating a new carbon economy where it can be traded, bringing a potential new stream of income to the cities as they grow. Today, a square kilometer of a city with its parks and its tree-lined streets can sequester around 20 tons of carbon per year. That is the equivalent of what 900 mature trees can absorb. Tomorrow, we should be re-envisioning the way in which the city could work as an ecosystem so that our cities are connected and regenerative. That same 1 square kilometer can bring economies of scale, exchanging resources from energy, water, and carbon. We actually need to utilize carbon in a positive and essential way that could develop into a new sector. We could equally use carbon absorption, where we could have it incorporated into our city streets and our surfaces. We could start with the way in which we think of our right-of-ways, and we could have more cycle and pedestrian-friendly friendly ways of increasing greenery and integrating rainwater management. Carbon capture byproducts can also be introduced in new types of paving surfaces and below-grade infrastructure. We could also use biochar, that is an off-product by biomass, to enrich the soil. Also, by intensifying the performance of our city parks, we can effectively combat climate change through a more intensive planting and integrated carbon sequestering materials. And finally, if we incorporate these ideas at the urban block scale, we can actually take advantage of this greater critical mass and expand on the impact of carbon capture to include a wider range of building types, and equally offer a new economy of sequestration through district-scale infrastructure and services. Through these district-scale interventions, we can sequester 1,500 tons of carbon per 1 square kilometer in a city in 1 year. This is nearly 70,000 trees. Comparing that with today, we could be absorbing 75 times the amount of carbon that same square kilometer of the city exists. We could reimagine the future health of our cities, our society, our economy, where we close the circular loop of life and enable every building, both existing as well as new, at any scale and at any given context, to become part of the solution.
An existing low-rise single-family home here in Glasgow may offer easy wins, such as maximize passive design with the integration of renewable energy technologies and specification of low-carbon, locally available, sustainable materials. We of course acknowledge that the historic fabric will pose challenges to the extent and application of new and emerging materials as well as technologies, such as carbon capture and biobrick I've mentioned before. In such scenarios, we need to work very closely together with the local municipalities and regulators to find opportunities to go beyond what the building regulations would enable us to do so today. Going farther east in India, in a mid-rise elementary school in Chennai, where the benefits of carbon capture may not be readily available or may not reach the mainstream fast enough. And this may be the case in many parts around the world. In such context, we need to ensure that we can capitalize the local context and benefit from the local knowledge, skills, and materiality to help deliver the carbon negative environments that we so desperately seek. We can bring nature into our buildings in such scenarios and help educate the next generation on natural materials, nature-based solutions, and regenerative built environments. In a much colder climate in Chicago, mid-rise hospital building, which will luckily have a very high energy need. In this scenario, we need to couple passive strategies with active systems and add renewable energy systems as well as carbon capture technologies to deliver a significantly low carbon built environment and reduce the environmental impact of this building typology. And finally, going back, scaling up to a high-rise building, a new office tower in Hong Kong. Here, an urban sequoia can actually sequester carbon in a densely city fabric, where the city is predominantly made out of concrete and steel, and where there's very limited land to actually offset carbon locally. Considering all, every city context and every building at scale can become a part of the climate change challenge we're facing today, where we can envision a carbon-free growth everywhere, in every city around the world. In New York, for example, which has the highest carbon footprint in North America, we can plant urban sequoias throughout the entire city, creating a network of carbon capture, storage, and exchange, and going well beyond net zero, delivering a carbon negative, even a carbon regenerative city. And in Lagos, which is one of the fastest urbanizing cities around the world, where a high-rise building may not be needed or even feasible, in these contexts, we can actually adopt the urban sequoia project idea to offer a unique solution that is very needed for this context. By maximizing passive design approaches coupled with bio-based materials and intensification of greenery, we can actually even offer new trade and crafts to the region. And in Rio, we can hopefully help reverse the trend of deforestation. As existing buildings get retrofitted with bio-based materials and carbon capture technologies, we may no longer need to clear the land for construction and infrastructure. And in Istanbul, in historic cities such as the beautiful Istanbul, which is my hometown, where the past gives identity to the future city, and where interventions and opportunities may be limited due to the dense historic city fabric. We need to ensure we can apply the right approaches from the Urban Sequoia project and find the right interventions that can deliver this built environment to be a regenerative one. And hopefully in this vision, the cities of the past can find their ways into a decarbonized future. To date, one of the main solutions to carbon reduction has been to plant trees. But as our population rapidly grows, we will not have the time or even the land area to meet the required carbon offsets. And therefore, we recognize that the challenge ahead is immense. But today, we're actually embracing innovation and collaboration beyond our sector and within our sector.
And to be able to create a global network of urban sequoia forests that could save 1.6 billion tons of carbon a year. This would be the same as covering the planet with 70 billion trees that would almost cover all of Europe. We look forward to the built environment contributing to planetary health, and we need to move forward together, collaborating across different sectors, and we must be visionary, and we must commit to bold actions, and all of them must come together. We'd like to thank all of you for the time, and also take this opportunity to thank for our key collaborators of Architecture 2030, the Open Air Collective, University of Colorado Boulder, as well as CMG Landscape Architecture.
We will be more than happy to take any answers. Thank you very much.
Thanks, Kent and Mina. That's fascinating talk. In terms of scaling up the technology, have you done any work on how rapidly and the mechanics of scaling up the carbon capture, the algae facades? Because I recognise the algae facade as a project we collaborated on actually with a German university. Yeah, I'd be keen to understand whether you did work within this study as to, what the levers are and how we might scale up some of these really, really challenging concepts.
Thank you, Chris, for that question. Yes, indeed, the algae facade is actually the research that has been done by the Arab and the German Institute. And there are many more great examples emerging of such technologies that we've presented here today by many others. So this is very much of a collaborative effort and idea we're presenting here today. And to answer to your question directly, we've very much focused on understanding the implications and the levers that we can pull for a single building to optimize it for this most challenging typology of a high-rise in this particular research. But as we continue, we will be able to offer much greater insights on how this can scale up beyond a single individual building. Of course, we have insights and sort of thinking about how this can become an ecosystem and a network, but we have not figured out exactly all the details of how it will all work out. But thank you for your question.
Hi, my name is Ruben. We are home builders in Mexico. We build communities, sustainable communities towards net zero. And we're starting to do a lot of changes on energy efficiency. What we have not achieved yet is a way to absorb CO2. Our biggest challenge is financing. A bio brick is extremely more expensive than a traditional brick. We have changed from a traditional brick to a structured brick, allowing us to save a lot of money on steel and also lower the CO2 or the GHG emissions. But putting something like BioBrick is basically out of the question for us. The type of homes that we build are $25,000 homes, and so we go for the social side. And it's a large home. It's 55 to 65 square meters. And but how can you do this? How can you access either cheaper finance or subventions that will allow us to absorb CO2 and then do a carbon market where we can sell that CO2 savings? How do you face that? How can you access that?
Well, a couple things. I'm enthused by everything that's happening in the last 2 weeks here and the way in which we're being able to connect these dots with people who are struggling in different areas of the world. Mm-hmm. But with the BioBrick as an example, where it's as simple as sand, water, and algae, that can be anywhere in the world. In fact, it can deal with a lot of the issues that we find in Africa. I mean, it's 3 very simple products to be able to do. So the idea of cost is probably the early knowledge that it takes to actually put that composite together. But in actual fact, that product is available, all those 3 items are on any continent, anywhere in the world. So I think that shows great promise on that particular product. There are more sophisticated ones like carbon capture and other ways in which we might do that. And again, there are systems that you can actually incorporate, as much as we don't like to talk about existing air conditioning units, you could actually install it and be part of that system and actually collect the carbon from within the air circulation that exists with very simple residential means in which we're actually moving air circulation around our homes at a very small scale, not to mention the ones that we've just showed in a new build where you actually can move much larger volumes of air through a building. So it's really opening up this discourse, opening up these discussions. It's sharing these ideas with the people in the room. And to be honest, these ideas are ready to go. They are available and they actually can be moving forward. I would like to talk to you after on the challenging of costs because I think it's ripe for the picking. I think there's a question back here. I'll hand over that microphone.
You have the floor.
Thanks. I guess it's a follow-up question to that, and it's very similar. It's like, what are the biggest hurdles for you? I mean, is it regulatory? Is it financing? Is it all these things, given that international codes vary, international political, social, cultural contexts vary? I mean, the urgency is huge, and you've got this very enticing, powerful vision. But how do we start to execute it, have collaborators, partnerships, etc.?
I think you win the question of the day. I agree with everything you've said. This is what I would say. When we talk about buildings, we have to increase the way we talk about the people that we bring together for a project. It's what we call a value chain. I think too often we've been working with our engineers, our architects, our builders, and our clients. This needs to completely change with regulators and being able to kind of challenge some of these, looking at building codes completely different, bringing insurance companies into the equation when we need to actually look at new ways to develop innovation. For too long, the construction industry has been afraid of risk. But in order to get where we need to go, innovation is going to have to come forward, and the risks are going to have to be taken. So I think it's actually just creating a very wide value chain and bringing all these people in this room together to solve these problems. They are possible. They're very achievable. We've proved to it today. But it's a matter of bringing all the right people together.
I would ask the question. I'm sorry I just came in a little bit ago, but I see the forest there. And one of my good friends, I'm here representing Solutions from the Land, and it's about agriculture providing solutions, you know, for everything that we do. And we do provide the food, fiber, and all those things that you're talking about. But I'm looking at the forest, and my friend Pat O'Toole is at another meeting. But, you know, in the Northwest, in the western U.S., the forests are dying because they've been not managed well. And well-managed forests will also not only clean the air, but hold the water and create lots of opportunities. He lives in the headwaters of the Colorado River, but their forests are dying because of disease, because of the insects that have killed it. We need to think about ways to utilize those dead trees and then reestablish the forests and allow them to grow the way Mother Nature needed them to grow. But not abandon them. I think we have to help manage and help Mother Nature take care of those, and we can use those materials then, as you talked about.
This is exactly the value chain that I'm talking about. It's bringing people like yourself to the table and come up with the ideas that we don't know. As Mina said, she was from Istanbul. I'm from outside of Seattle. So again, we have a very kinship in that regard. And I know exactly the issues you're doing. We're talking with other types of industry as well, with their byproducts of what is created in manufacturing and,
sure.
and ceramics and other things, of how we actually could integrate that into our buildings. But the same thing goes for our natural resources as well, and finding that. Forests are absolutely key to this, but what we're saying is forests can't do it alone. We actually need to find buildings that also can sequester carbon. We can't just throw that on the forests to solve that problem, because we're going to run out of land.
Yeah, appreciate it.
Thank you for the question.
I'll give you my card in a little bit.
All right.
I thought it was really interesting, the potential for cascading carbon benefits in the rest of the urban system that you described. So the increased growth of urban agriculture by providing a feedstock for part of its supply chain, and also things like synthetic fuels, which can be made from captured carbon. So are there any other kind of key cascading benefits in the whole urban system that you guys are anticipating with something like this?
I think you've listed actually many of them, but the majority of it that we think could be very beneficial immediately, especially for the perhaps selfish looking at the built environment sector, is the opportunities to use as an alternative energy source. And to, especially as the cooling demand will continue to increase with the rising global temperatures, we will actually be able to utilize especially the algae and others that we talked about, and the carbon that can be captured through the carbon capture technologies to find a source for refrigeration in buildings. So I think that will be probably the best and the most immediate one that will be needed.
That's all the questions. I'm happy to field some afterwards, but again, I'd just like to thank everybody for attending, and again, start to become part of this value chain. We need you.